Module 9, Lecture A, Using Standard Modules. By the end of this lecture, you will be able to import Python standard library modules using different import styles, use functions from modules like math, random, and datetime in simple examples, and consult basic documentation to discover functions and understand their parameters. Importing standard modules. Basic import syntax. As you move to more complex tasks in Python, its real power comes from modules, which are collections of tools that extend what the language can do. You bring these modules into your program using the basic import statement. When you import a module, you treat it as a single named object and use that name to access its tools. This keeps a clear separation between your own code and the functionality provided by the module. Using the basic import style in Python encourages you to think in terms of namespaces, which act like labeled containers that keep different parts of your program separate. When you import a module this way, you access everything in it through the module's name, which makes it clear where each tool comes from. This approach helps prevent name conflicts and keeps your code easier to understand, especially in larger programs where different modules might define tools with similar names. Using the basic import style in Python improves readability and collaboration in both academic and professional code. Clear import lines at the top of a file quickly show which modules a program depends on, whether it is for data analysis or automation. Keeping the module name visible whenever you call its functions reminds you where those tools come from, reduces confusion, and helps with debugging. It also makes it easier to look up details in the documentation, since you always know which module to search for. Python code. Basic import syntax. This section focuses on showing beginners how to import a module in the simplest way, then use its tools by referring to the module name. It explains that once a module is imported, you can access its functions or other features through that name. Finally, it emphasizes printing some results so learners can clearly see that the import worked and understand how the module is being used in practice. This line is telling you that you do not need to run any pip install commands for the modules used in this script. They are all part of Python's standard library. That means they come pre-installed with Python. As a result, you can use them right away without any extra setup or installation steps. We begin by importing the math module, so we can use its built-in mathematical functions and constants. This lets us access operations like square roots and trigonometric functions by referring to them through the module name. Using the module in this way helps keep the code organized and clear, especially when working with several different modules in the same program. In this example, we use the math library to calculate the square root of 144 and store the result in a variable. By calling the square root function from the math namespace, we access a specific mathematical operation provided by the library. This shows how the math module helps perform precise mathematical calculations in a program. We begin by importing the random module using the standard import statement. This gives us access to all of its functions and tools by referring to them with the module name first. Using this basic import style keeps the code clear and organized, especially when working with several modules. It also helps prevent naming conflicts with other parts of the program. The random module can be used to generate a random whole number. When you call its randint function with the values 1 and 6, it returns a random integer between 1 and 6, including both ends of the range. This effectively simulates rolling a six-sided die. More generally, this approach is useful whenever you need a random number within a specific range. We begin by importing the datetime module, so we can work with dates and times in our program. This module provides built-in tools for handling dates, times, and time intervals. By using datetime, we can perform common date and time operations more easily and in a consistent way. We use the datetime module to obtain the current date in our program. By calling the today method from the date class inside this module, we get today's date. This date is then saved into a variable so it can be used later wherever the program needs the current date. This code prints the results of 3 operations, each labeled with the module that performs it. It first calculates the square root of 144 using the math module. It then generates a random whole number between 1 and 6 using the random module. Finally, it shows today's date using the datetime module. Together, these outputs illustrate how to call and use functions from different Python modules. This script shows how to import and use basic Python modules from the standard library. It uses the math module to compute the square root of 144. The random module to generate a random integer between 1 and 6 like a dice roll, and the datetime module to get today's date. The program then prints each result with a clear label. Overall, it demonstrates how to call standard library functions through their module names to perform common tasks. From import basics. The from import style lets you bring specific functions or constants from a module directly into your code, so you do not have to repeat the module name each time you use them. You can think of it as selecting only the tools you need from a larger toolbox. This makes your code lighter and easier to read, especially when you rely heavily on just a few parts of a large module. Using the from import style is helpful when you repeatedly use the same function, such as rounding numbers or generating random choices. It keeps your code shorter and more focused because you do not have to mention the module name every time. This makes programs, especially in tasks like data analysis or simulations, easier to read and understand when you come back to them later. Overall, it lets your code flow more naturally by giving you direct access to the key functions you use most often. When you use the from import style, be careful about name collisions, where imported functions or constants have the same names as ones already in your code. This is usually not a problem in small scripts, but in larger or shared projects, it can make it unclear where a name comes from. For this reason, many developers use this style mainly for a few well-known functions to reduce confusion. As you gain experience, you will learn how to balance the convenience and readability of this approach with the clarity of keeping functions clearly tied to their original modules. Python code. From import basics. This section demonstrates how to use the from import style with simple math and random examples. With this approach, you bring specific tools directly into your program so you can use their names without saying the module name first. It shows that you are not importing the entire module, but only selected functions or features. This highlights how you can pick just the tools you need, from larger standard library collections to keep your code focused and clear. In this line, we are pointing out that there is no need to run any pip install commands because the code only uses modules from Python's standard library. All required modules come bundled with Python itself. As a result, everything needed is already available, and you do not have to install any additional packages. We import specific functions from the math and random modules so we can use them directly without saying the module name each time. From the math module, we bring in the square root function, which finds the square root of a number, and the ceiling function, which rounds a number up to the nearest whole number. From the random module, we import the function that generates a random integer within a chosen range. This focused import style keeps our code simpler and more readable by including only the functions we actually need. We begin by setting a variable to represent the distance we want to convert, which is 2.5 miles. We then set another variable to the constant number of feet in 1 mile, which is 5,280. With these two values defined, we are ready to use functions from the math module to perform the calculation that converts the distance from miles into feet. To find the number of feet in a given distance in miles, first multiply the miles by the number of feet in 1 mile to get an exact value in feet. Then apply a ceiling operation, which rounds this value up to the next whole number. This step ensures that any fractional part of a foot is included, so the final answer is a clean whole number of feet. We use a function called randint from the random module to generate a whole number between 1 and 10. Because we imported this function directly, we can call it without saying the module name first. The random number it returns represents extra feet added to a distance calculation. This introduces variability into the final distance result. To find the final distance in feet, we add the rounded number of feet from the mile conversion to the extra random feet. This combines the calculated distance, which has already been rounded, with an additional random amount. Using simple addition, we get one total distance in feet that includes both the precise conversion and the random component. The code prints 3 results: the exact number of feet calculated from a distance in miles, the same value rounded up using the ceiling function, and a final value after adding a random extra amount. Together, these outputs show how mathematical functions like square root and ceiling can be used directly without repeating the module name. This is possible because the functions were imported using the from import style, which lets you call them more simply in your code. This script shows how to use the from import style to bring in specific functions from Python's math and random libraries so you can call them directly without the module name. It converts a distance in miles to feet, then uses the square root and ceiling functions to work with that value and round it up to the nearest whole number of feet. It also generates a random extra number of feet and adds it to the total. When you run the code, it prints the exact feet, the rounded feet, and the final feet, illustrating how these imported functions fit smoothly into calculations. Module aliases. Using module aliases means giving a module a shorter or more meaningful name when you import it, which makes your code easier to read and maintain. This is especially helpful in larger programs that use many modules because it keeps the code concise and visually clear. In situations like data analysis scripts, a short alias for a long module name reduces clutter and makes the purpose of each line easier to understand, even when the code is read aloud. Using standard aliases in your code makes it easier to read and collaborate on, because it matches what most programmers expect to see. In many areas, certain modules are almost always imported with the same short name, so experienced developers can quickly recognize what kind of functionality is being used. By following these common conventions, you help others and your future self understand the code more quickly. This is especially useful in scientific computing, where consistent aliases make it easy to spot operations related to math, dates, or randomization at a glance. When choosing aliases in your code, make them clear and purposeful so they simplify rather than confuse your logic. An alias should be short but still suggest what the module does, and it should not overshadow other important names. Using distinct sensible aliases, such as one for handling dates and another for generating random data in a financial tool, helps you quickly see whether code is about scheduling or creating sample transactions. Over time, consistent aliasing builds a visual vocabulary that makes it easier to read and navigate complex code. Python code, module aliases. This section explains how to use module aliases in Python, with simple examples from the standard library. It shows that giving a module a shorter alias can reduce repeated long module names and make code easier to read. The narration compares code that uses the full module name with code that uses an alias and uses clear printed output to highlight how the two approaches differ. The focus is on demonstrating the practical benefit of aliases without changing what the code actually does. The comment is explaining that you do not need to run any pip install commands for this script because all the modules it uses are part of Python's standard library. In other words, they come bundled with Python by default. Since they are already included, there are no extra installation steps required. This makes the modules immediately available in any normal Python environment. In this script, we import the math module without giving it a shorter alias, so we always refer to it by its full name. This lets us clearly show which functions and constants come from the math module. We do this to compare the experience of using the full module name with using an alias, especially when the module is used many times. This approach can improve clarity when the module name is short and when you want to emphasize where each function originates. We import the datetime module using the shorter name dt so we can refer to it more easily in our code. Using this alias makes the code more concise and readable, especially when we need to use the module many times. This simple change helps keep the code cleaner and quicker to write, while still providing full access to everything in the datetime module. We import the random module and give it a shorter alias called rnd so we can refer to it more easily in our code. Using this alias means we do not have to type the full module name every time we call one of its functions. This simple change helps keep the code cleaner and more readable, especially when we use the module often. We set the radius of the circle to 5 inches so we can calculate its circumference. With the radius defined, we apply the circumference formula, which multiplies 2 times pi by the radius. This example also shows how to use the math module without an alias to perform the calculation. In this example, we calculate the circumference of a circle using the math module without giving it a shorter name. We take 2 times the value of pi from the math module and then multiply that by the radius of the circle, stored in a variable measured in inches. This product gives us the circumference. Using the full module name here helps keep the code clear and explicit. In this example, we import the math module but give it a shorter alias, calling it m. This lets us refer to the math module more concisely throughout the code. Using an alias can make the code cleaner, especially when the original module name is long. It also improves readability when the module is used frequently. In this example, we calculate the circumference of a circle using an alias for the math module. By importing the module with a short name, we can refer to the constant pi more quickly. We then multiply 2 pi and the radius stored in inches to get the circumference. This shows how using a module alias can make repeated calculations more concise and readable. We use the datetime module, imported with a shorter alias, to create a specific calendar date in a cleaner, more concise way. By calling its date creation function and passing a year, month, and day, we build a date object that represents July 4th, 2025. This date object can then be used in a program for tasks like scheduling events or comparing different dates. In this example, we use the random module, imported with a shorter alias, to generate a discount percentage. A function from this module produces a random whole number between 5 and 25, including both endpoints. This number represents a simulated discount that might be used in a test scenario. Using an alias for the module helps keep the code more concise and readable, while demonstrating how random values can be generated. We calculate and print the circumference of a circle using the full name of the math module, and we round the result to 2 decimal places for clarity. This example highlights that calling functions with the complete module name works correctly, but is more wordy. It contrasts this approach with using a shorter alias, which can make code less verbose while producing the same result. In this step, we print the circumference of a circle that was calculated using an alias for the math module. The print function shows the label for the circumference in inches, followed by the computed value. To keep the result easy to read, we use the round function on the stored circumference value, so it is displayed with only 2 decimal places. In this step, we print the scheduled report date that was previously created using the datetime module, which we imported with a shorter alias to make the code more concise. Printing the report date shows the specific date that was set earlier, July 4th, 2025. This example illustrates how using an alias for a frequently used module can make the code cleaner and easier to read, while still giving us full access to its functionality. This line of code prints the random discount percentage that was generated earlier using the random module, which was imported with a shorter alias. The output shows the label for the random discount percent, followed by its actual value. Using an alias for the module makes the print statement and the rest of the code more concise and easier to read, especially when the module is used many times. This script shows how using aliases for Python modules can make code shorter and easier to read without changing what it does. It first calculates the circumference of a circle with the math module using its full name. then repeats the calculation using a shorter alias and confirms the results match. It also assigns an alias to the datetime module to create a specific date, and to the random module to generate a random discount percentage. By printing these values, the script illustrates that aliases simply provide convenient shorthand while preserving the original functionality. Everyday Standard Modules. Math Module Basics. The Math module in Python is a built-in collection of mathematical functions that saves you from writing them yourself. After adding it to your program, you can easily compute square roots, powers, logarithms, and trigonometric values. These operations are important in areas like measurements, geometry, physics, and finance. In practice, this means you can quickly handle tasks such as design calculations, growth estimates, and angle conversions using reliable, ready-made tools. The Math module provides functions that expect specific input types and usually return floating point numbers. For example, you can compute a square root by giving a positive number, or find sine and cosine using angles measured in radians. Because trigonometric functions use radians, you often need to convert familiar degree values like 90 or 180 into radians. Knowing these input and output rules helps you combine math functions effectively to solve more complex problems, such as those involving motion or repeating patterns. The Math module in Python provides high-precision constants, such as the ratio of a circle's circumference to its diameter, and the base of natural logarithms, which are important when small numerical errors can build up in areas like manufacturing, population studies, and digital signal processing. It also includes functions for rounding, absolute values, and comparisons that help manage numerical approximations in practical tasks like reporting and billing. Learning to use these tools effectively builds a foundation for solving more complex numerical problems in data analysis and scientific computing. Python Code Math Module Basics. This lesson shows how to use basic functions from the Math module through simple, everyday-style calculations. You will see how to compute square roots, convert angles between degrees and radians, and find the area of a circle using built-in math constants. The results are printed clearly, so beginners can easily match each input with its corresponding output. The goal is to make these core math tools feel straightforward and practical to use. The Math module is a built-in Python library, so you do not need to install anything to use it. It is available immediately in any Python program and provides functions for common mathematical operations. These include tasks like computing square roots, performing trigonometric calculations, and using constants such as pi and e. This makes it convenient for many types of computational work that rely on standard math tools. In Python, we often begin by importing the Math module, which is part of the standard library and does not require any extra installation. This module gives us access to many advanced mathematical functions and constants. By using it, we can easily perform operations such as trigonometric calculations, logarithms, and other complex math tasks with built-in tools. We begin by setting the length of one leg of a right triangle to 3 feet. This fixed length will later serve as the side of a square. Using that square, we will calculate the length of its diagonal. This provides a practical example of how the Pythagorean theorem can be used to find the diagonal from the side length. To find the diagonal of a square with sides of 3 feet, we apply the Pythagorean theorem. Since the square's diagonal forms the hypotenuse of a right triangle with two equal sides, we square each side length, add those squares, and then take the square root of that sum. In practice, we can use the square root function from the math module to compute this diagonal length. We calculate and report the length of the diagonal of a square whose sides are 3 feet long. This diagonal is found using the Pythagorean theorem. We then round the result to 2 decimal places to make it easier to read and understand. The final value clearly shows the outcome of the calculation. We set an angle to 45 degrees, a standard example often used in trigonometry and geometry. Defining the angle in degrees makes it easy to understand and work with. We then prepare to convert this degree measure to radians, which is the form required by many mathematical functions. We start with an angle measured in degrees and convert it to radians so it can be used with trigonometric functions in Python's math module. These functions, such as sine and cosine, expect angles in radians, not degrees. To handle this, we apply the radians conversion function from the math module and store the result as the angle in radians. This prepares the value for any further trigonometric calculations. To find the sine of an angle, we use the sine function from the math module, which expects the angle to be given in radians. Before calling this function, the angle must be converted from degrees to radians. The function then returns the sine of that angle, which is a standard trigonometric value used in many calculations. We calculate and print the sine of an angle after first converting the angle from degrees to radians. The sine result is then rounded to 3 decimal places to make it easier to read. This rounded output helps confirm that the trigonometric conversion and calculation were done correctly. We set the radius of a circular table to 18 inches. This fixed radius will be used later to find the table's area. To do that, we will apply the standard formula for the area of a circle, using this radius value in the calculation. To find the area of a circular table, we use the value of pi from the math module and multiply it by the radius of the table measured in inches taken to the power of 2. This calculation follows the standard formula for the area of a circle. The result gives the table's area in square inches. This code calculates and prints the area of a circular table. It uses the pi constant from the math module and a radius of 18 inches. The computed area is then rounded to 1 decimal place for clarity. Finally, the program prints the rounded area in square inches. We calculate a growth factor using the base of the natural logarithm, called e, by raising e to the power of 2. This models a situation of continuous growth over a certain time period. The resulting value represents exponential growth and is useful in many mathematical and scientific applications. We are calculating the natural logarithm of a quantity called the growth factor. This quantity is equal to the number e raised to the power of 2. When we apply the natural logarithm to this value, the result is approximately 2. This happens because the natural logarithm and exponentiation with base e are inverse operations, so one undoes the effect of the other. This line prints the result of a natural logarithm calculation. It uses the math log function to compute the natural log of a growth factor equal to e raised to the power of 2. The result is rounded to 3 decimal places for clarity. The printed output shows that the natural log of e squared is approximately equal to 2. This script shows how to use basic functions from the math module to perform common calculations. It finds the diagonal of a square with 3-foot sides using the Pythagorean theorem, giving about 4.24 feet. It converts a 45-degree angle to radians and computes its sine, which is about 0.707. It also calculates the area of a circular table with an 18-inch radius, giving roughly 1,017.9 square inches, and demonstrates the natural logarithm by taking the log of e squared, which is approximately 2. Each of these results is printed in a clear, readable format. Random choices, basics. The random module is used when your program needs to make decisions that are not fixed in advance. It lets you simulate unpredictability in a controlled way, such as choosing which game enemy appears next, or shuffling flashcards so their order is not memorized. You can also use it to randomly pick a student's name for an activity or to introduce unexpected options in a recommendation system. In all these cases, you start with a set of possible outcomes and rely on the random module to select among them, so the process feels random to users while still being reproducible and testable for you. The random module lets you work with sequences, such as lists, by selecting or rearranging elements in an unpredictable way. You can use it to randomly pick one item from a list, like choosing a movie suggestion. You can also shuffle a list, for example, to mix up study topics and keep practice sessions varied. In simulations, such as modeling customer arrivals, random choices help you explore different possible patterns without manually defining every outcome. Random choices are useful for modeling decisions that follow certain patterns or constraints. In a quiz app, for example, shuffling answer positions helps prevent users from guessing based on order, and in clinical trials, randomly assigning participants to groups reduces bias and reflects real research practice. Randomness can also drive creative tasks, such as generating musical variations or color palettes from a defined set of options. By practicing these kinds of scenarios, you learn how to use randomness to make programs more dynamic and engaging, while still keeping control over the overall behavior. Python code. Random choices basics. In this lesson, you will see how to use the random module to make choices from lists so your programs can behave differently each time they run. We will show how to select a single random item, how to pick several random items, and how to shuffle the entire list into a new order. Through these simple examples, beginners can observe how randomness affects program output and understand that the results can change on every execution. The key point is that you do not need to install the random module separately because it is already included in Python's standard library. This means it is built in and ready to use as soon as you install Python. As a result, you can immediately use it for tasks that involve randomness without any extra setup. We begin by importing the random module from Python's standard library so we can add variability to our program. This module offers tools for making random choices and rearranging items, which lets our code behave differently each time it runs. By using random, we can select random elements from a list or shuffle the order of items, enabling more dynamic and unpredictable program behavior. We begin by creating a list of names that represents a group of students, such as those in a classroom. This list serves as a collection we can use later in the program for tasks like randomly choosing a student. Setting up this list is important because it provides a simple, realistic example of how randomness can be applied, such as picking someone to answer a question. We use a tool from the random module to pick one student from a list of students. A function in this module selects a single element from the list, and the selected student's name is stored in a variable. This lets the program randomly choose which student will answer a question. It shows how randomness can be used to make decisions in a program. This code randomly selects one student's name from a list and prints it out. It uses randomness to choose a single individual from the group, then displays a short message saying that this student has been chosen for the day. In doing so, it provides a simple, practical example of how randomness can be used in a real situation. We create a list of movie titles to use as our collection of choices for a movie night picker. This list groups all the options in one place so the program can work with them easily. Once the titles are stored in the list, the program can manipulate them or randomly select one, making the movie choice dynamic and varied each time it runs. The code uses the random module to shuffle the list of movies, changing their order in an unpredictable way each time it runs. This produces a new sequence of movie titles on every execution. Such shuffling is useful when you want a random playlist or need to decide the order of events without bias. This code shows how the random module can shuffle a list of movies and then print their new order. Each time the code runs, the movies appear in a different, unpredictable sequence. This demonstrates the effect of randomness on the list and how it can be used to create variety, such as when planning a movie night. We create a list called snacks that holds several snack choices, each labeled with its weight in ounces. This list represents the different options available for a movie night. Later in the program, we can use this list to randomly pick a snack or change the options as needed. We use the sample function from the random module to pick two different snacks from a list. This function selects items without replacement, so once a snack is chosen, it will not be selected again in the same draw. As a result, the two snacks are always distinct, which ensures variety and prevents duplicates. This code randomly selects several snacks from a list and then prints the chosen items. Its main purpose is to show how you can make multiple random choices from a collection. The selected snacks are stored together, and the print command displays them on the screen. This provides a simple, clear example of how randomness works in a program. This script uses the random module to add variability to a program's behavior. It randomly picks one student from a list to show how randomness can decide outcomes, such as who answers a question. It then shuffles a list of movie titles to demonstrate how to create a new order each time. Finally, it selects two different snacks from a list without repeating any choice. Because of this use of randomness, each time the script runs, it produces different results. Working with dates. When working with time and Python programs, it is important to use the language's date tools so dates and times are handled as structured objects instead of plain text. This lets you compare dates, measure time differences, and record events accurately. By treating time as rich data rather than simple strings, your programs can interact more reliably with real-world timing and scheduling. Using date and time objects makes everyday programming tasks much easier. You can capture the current date and time from your system, store it as an object, and then calculate durations such as the days until a university term starts or how long an invoice has been outstanding. You can also compare a project due date with today's date to trigger reminders. Built-in functions handle calendar details like varying month lengths, so you do not need to manually count days or manage these complexities yourself. When working with dates in programs, you often need to convert between human-readable strings and internal date objects. For example, dates from web forms are turned into date objects, so you can compare them or store them in a database, then later formatted again for display in emails or on web pages. You also need to adapt date formats to different regional styles and handle time zones correctly, especially for global events like online meetings. Mastering these skills helps your programs work reliably in real-world situations. Python code. Working with dates. This lesson shows how to use the datetime module to create and compare dates, including calculating how many days remain until a simple project deadline from today. You will also learn how to format dates so they appear in clear, readable messages. Finally, it briefly notes that you might install an external library with a package manager, even if that library is not directly used in the examples here. We begin by importing the datetime tools from Python's standard library so we can work with dates and times in our script. These tools let us create date objects, measure the time between two dates, and format dates for display. This setup is essential for tasks like finding the current date, defining a future deadline, and calculating how much time remains until that deadline. We begin by asking the system for today's date using a function from the date module and store that result in a variable. This gives us the current date at the moment the program runs. Having this value is essential for any task that relies on the present date, such as computing deadlines, tracking durations, or scheduling time-based operations. We set a project deadline by starting with today's date, using the current year, month, and day. Then, we add a time interval of 10 days to this date. This gives us a new date that is exactly 10 days from today. With this deadline set, we can easily determine how much time remains until the project is due. To find how many days remain until a project deadline, the program subtracts today's date from the deadline date. This subtraction produces a time difference object that represents the duration between the two dates. The code then reads the day's value from this object to get the remaining time as an integer. Finally, it uses this number to inform the user how many days are left until the deadline. We start with today's date, which we already have, and convert it into a more readable form. To do this, we use the strft method from the datetime module. We specify a format that shows the month, day, and year so the date is clear and easy to understand when it is printed or displayed. This code takes the deadline date and converts it into a clear, human-readable string. It uses a date formatting method from the datetime module to turn the date object into text. The result shows the month, day, and year in an easy-to-understand format. This makes the deadline quick to read and interpret at a glance. This code prints a message that includes today's date and the project deadline in a clear, friendly format. It uses a formatted string to insert the dates, which have already been converted into readable text. By turning the date objects into human-friendly strings that show the full month name, day, and year, the output becomes easier for users to understand. The code checks whether the number of days remaining until the deadline is greater than 0. This condition tells us if the deadline is still in the future. If it is true, there is still time left before the deadline arrives. The code checks how many days remain until the project deadline and uses the previously calculated number of days between today and the deadline. If there is still time left, it prints a message showing the remaining days. This simple output helps the user keep track of how much time they have to finish their project. This part of the program checks how many days are left until a deadline and prints a message if the deadline is today or has already passed. When the number of days remaining is 0 or negative, it means the deadline is no longer in the future. The printed message clearly informs the user that their deadline has arrived or is overdue. This script uses Python's date and time tools to track a project deadline. It reads today's date from the system, then sets a deadline 10 days in the future and calculates how many days remain. Both dates are converted into an easy-to-read month, day, and year format and printed out. Finally, the script reports either how many days are left or that the deadline is today or has already passed, providing a simple way to monitor time-sensitive tasks. Reading module documentation. Using the help function. You can explore what a module can do by using the built-in help system. It tells you the purpose of a module or function, what arguments it needs, and what it returns. Asking for help on a module gives you an overview plus a list of its functions and classes. Asking for help on a specific function shows what it does, its parameters, and often default values and return types. This makes the help system a key resource for understanding and using modules without leaving your coding environment. When using a help system, focus on the function's parameters and what their names suggest about their roles. Parameters with default values can usually be left alone at first, which lets you rely on sensible starting settings. Names like start or stop often indicate limits, and a parameter called seed in random functions controls reproducibility. By paying attention to these details, you can quickly see which parameters are essential to use now and which you can experiment with later to fine-tune the function's behavior. Once you are comfortable with the help system, use it to explore modules, not just to look things up. For a data analysis project involving dates and times, begin by reading the module overview and its contents. Pay attention to functions that parse dates, format them, and compute time differences, and then examine each one to understand its parameters and typical use. By practicing this kind of systematic exploration, you will build a stronger understanding of the standard library and be better able to choose the right tools for tasks like scheduling or precise time calculations. Python code. Using the help function. Use the interactive help system to explore modules and functions, focusing on how to view their descriptions, parameter names, and default values. Practice reading this information so you can clearly understand what each function expects as input. Then compare the brief help summaries with actual function calls and their printed results to see how the documented behavior matches what happens in practice. This part of the code explains that you do not need to install any extra packages with pip because the script only uses modules from Python's standard library. In other words, everything required is already included with Python. This reassures users that they can rely on the built-in features and do not have to manage external dependencies. We begin by importing the math module so we can use Python's built-in mathematical functions and constants. In this script, the math module lets us work with operations such as finding a square root. We will also use it to show how to access the help documentation for specific functions. This helps you understand what each function does and how to use it correctly. We use the random module to access functions that generate random numbers. This module is included in Python's standard library and does not require any extra installation. It provides tools for creating random values, which are especially useful in simulations, testing, and other tasks that need unpredictable data. We use the help function to get the documentation for the square root function from the math module and store that information in a text variable. This documentation explains the function's parameters and how to use it. By reading it, we can understand how to call the square root function correctly and what kind of result it will return. We use the square root function from the math module with 16 as the input, which computes the square root as 4. Then we display a message that states the square root of 16 equals the calculated value. This shows how to call a math function and present its result clearly. We use the help function to get the documentation for the random integer function from the random module and store that text in a variable. This gives us quick access to information about what the function does, what parameters it takes, and how to use it. Having this documentation readily available makes it easier to understand how to call the function correctly in different situations. We use a random integer function from the random module and specify a range from 1 to 10. This function returns a whole number within that inclusive range, so both 1 and 10 can appear as results. We then print the value and state that it is a random integer between 1 and 10. This simple example shows how the function behaves and lets us immediately see its output. This example shows how to call the random integer function from the random module with a range from 1 to 10 and print the result. It illustrates how the arguments you provide correspond to the description in the help documentation. By comparing the output and the help text, you confirm that the function behaves as described and that the parameters you used are correct. This script shows how to use Python's help function to explore documentation for standard library modules. It first displays the help text for the square root function from the math module, then uses that function to compute the square root of 16. It then shows the help text for the random integer function from the random module and calls it twice to generate integers between 1 and 10. Overall, the exercise demonstrates how to read function documentation interactively and confirm that the function's behavior matches what the documentation describes. Browsing online documentation. Once you move beyond basic programming, knowing how to use official online documentation becomes essential. For Python, the main documentation site is organized by topics and module names, and each module page starts with an overview of its purpose, followed by descriptions of its functions, classes, and constants. Learning to quickly scan this structure helps you find what you need and skip what you do not, instead of relying on incomplete sources. This skill lets you understand how functions really work without guessing. When reading online documentation for a function, pay attention to how it is described, including its name, what it does in plain language, its parameters, and what it returns. Note details such as whether a function returns an integer or a decimal number, what arguments are required or optional, and what types of data it expects. Understanding these points is essential, especially when you combine functions from different modules, so that the output of one function is compatible with the input of another. When browsing online documentation, rely on the built-in navigation tools instead of only scrolling. Use the table of contents or sidebar to jump quickly to sections like basic usage or advanced features, and use the search box to locate specific functions or concepts. These tools help you move efficiently between related modules, build a mental map of what the library can do, and feel more confident finding the right tools for new programming tasks. Finding examples. When learning a new module, studying concrete examples of its functions in real programs is essential for moving from theory to practice. These examples connect dense documentation to real-world problems by showing how functions actually work together. Seeing a function used in a simple task like simulating dice rolls or scheduling reminders makes its purpose clearer than just reading about its parameters. By analyzing such examples, you start to recognize common usage patterns that you can adapt for your own projects. When you read documentation, treat the examples as your main learning tool. Focus first on the problem the example is solving. Then connect each function call to its description and think about what each argument and parameter is doing. Pay attention to how outputs are used, and in cases like date formatting, how changing the format affects the result. This kind of careful, step-by-step analysis turns examples into guided practice and helps you understand the author's reasoning, so you can apply the same ideas on your own. To get real value from examples, do more than just read them. Actively modify them to suit different situations. For instance, change a fixed-length password example to produce different lengths or exclude certain characters, and adjust date parsing examples to match formats used in your region. As you make these changes, refer to the documentation to learn what each parameter does and which values are allowed. This hands-on experimentation helps you internalize how the module works, so you can confidently build your own solutions without depending on pre-made examples. Python code, finding examples. In this lesson, you will learn how to find examples in the documentation and adapt them to your own needs. You will see how changing different parameters in simple module functions affects their behavior. You are also encouraged to go beyond the original examples in the documentation and experiment on your own to deepen your understanding. The comment explains that you do not need to run pip install for the modules used in this script because they are part of Python's standard library. In other words, these modules come bundled with Python itself. Since they are already included, there is no extra installation or setup required. This reminder helps users understand that these tools are immediately available for use. We begin by importing two key modules. The random module lets us generate random numbers or make random selections, which we will use to create a password by choosing characters at random. The datetime module lets us work with dates and times so we can format and manipulate date information. These imports provide the basic tools needed for the upcoming examples on password generation and date formatting. We begin by defining a pool of characters made up of uppercase letters and digits, similar to what you might see in password examples from documentation. This pool is the source from which characters will be randomly chosen to form a password. We then set the password length to 8 characters, following a common example length often used in documentation. Together, this character pool and chosen length define how the sample password will be generated. This example shows how code can generate a random password using a function from the random module that selects characters from a predefined set. The length of the password is controlled by a separate variable, similar to how documentation often demonstrates password generation. The selected characters are combined into a single string and stored as the generated password. Finally, the code prints the password and its length, so you can see the result and understand how the process works. In this example, we change the password length to 12 characters so we can create a longer password. We then use a random selection function to pick characters from a predefined set and combine them into one string. The result is a password that matches the new length. This shows how adjusting the length setting lets you adapt the password generator to different requirements. This line prints a custom password that was generated using a longer length than in the original example. By showing both the chosen length and the resulting password, you can see how changing the length setting alters the output. This illustrates how flexible the random choices function is when you adjust documentation examples to fit new requirements. We begin by creating a date object with the datetime module set to July 4th, 2025 at 3:30 in the afternoon. This serves as a concrete example of working with specific dates and times. We then define a format string that controls how this date will be displayed. The format includes placeholders for the month, day, year, hour, minute, and whether it is AM or PM. This demonstrates a common pattern used in documentation to present dates in a clear, readable way. We take a date object that represents a specific moment in time and convert it into a text string using a formatting method from the datetime module. This method uses a format description that tells it how to arrange the parts of the date and time. In this example, the format is chosen to display month, day, year, hour, and minute in a common American style. We then print the formatted string to see exactly how the date appears, which helps us understand how this documented formatting pattern behaves in practice. We create a new date format that shows the full weekday name, full month name, day of the month, and year, making the output more descriptive and user-friendly. using the same date object as before. We apply this new format with a formatting method from the datetime library. This method converts the date into a string that follows the updated format. Finally, we display the formatted date so we can see the result of the new, more detailed style. This script shows how to adapt basic documentation examples in Python's standard library to better fit your needs. It first uses the random module to generate a password, starting with a common 8-character version and then changing it to 12 characters to demonstrate how adjusting parameters changes the result. It then uses the datetime module to format a specific date, beginning with a standard date and time format and then switching to a more descriptive style. Overall, it highlights how modifying parameters and format strings lets you customize behavior beyond simple default examples. In this lecture, you learn to import Python standard library modules using different import styles. Use functions from modules like math, random, and datetime in simple examples. And consult basic documentation to discover functions and understand their parameters. In the next lecture, Lecture B, we will go over organizing your code. Thank you for your attention. See you all in the next lecture.